Now let's start with the presentation. Like you all know that, as we all know that the water and sanitation plays a very vital role in the urban sectors. So, and in case it remains untreated, it can cause a great hazard, environmental as well as health hazards. Fine. And hence these issue needs to be addressed, and it's a great challenge nowadays to adapt the latest smart technologies to get rid of such problems. Fine. Then even the foreign funding investment, like you have ADB, World Bank, and you have GNURM schemes, where they are taking interest in water and wastewater sectors, because such projects are of vital importance. And here comes the need of the automation. Now let's see a symbol of water cycle, wherein we have a pumping station. The raw water source comes from the maybe some river or a reservoir. It's pumped into the treatment plant, and where you have a various process of the treatment plants, like you have clarification, you have filtration, and you have the sludge management system there. Then finally the water goes to the desalination plant, and then it's taken to a tank station or a booster station, where it's being pumped to the household societies, to the industries for their use. And then finally from there the water, the waste is coming to the lifting stations, and then it enters into the wastewater treatment plant, that is a sludge treatment plant. And there also you have a various technologies, latest technologies. You have aeration, you have sludge digesters, and wherein you produce the gas. Gas generation is produced from the sludge treatment plants. And then it's restored, the gas is restored in a natural environment. Then what are the nowadays challenges which we are facing? What are the challenges basically? It's ensuring a reasonable availability of acceptable quality of water, because everybody is health conscious. So obviously we need a better quality of water. Fine. And then geographically dispersed pump and booster stations. You have a booster stations which are at various remote locations, that is hundreds of kilometers, and it is very difficult to manage the assets for those. And you have to maintain the operation and maintenance spares for those booster pumps and all that, all the mechanical items. And then you have a high energy consumption across the system, which plays a very vital role, because energy efficiency is becoming a very critical thing these days. And it's a basic, it's a part of the OPEX, that is the operating cost. So if your system is energy efficient, the system will run for a long time. Then there comes the NRW. NRW is the non-revenue water. That is the leakages we are getting in the water, like water leakages, and then we have to protect those leakages. Like we have to put the, we have to install pressure transmitters, flow transmitters to monitor those leakages. Then the aging assets and downward pressure on operating budgets. Once your assets are being aged, they need maintenance. Hence your operating pressure, that is your budget, goes up for the operation and maintenance, because you have to maintain more and more spares. Now what are the solutions? We are basically looking for the solutions, because nowadays you must be hearing about the burning, that topic about muft bijli, muft pani, but it's not that. Until and unless you don't adapt latest technologies, like you don't adapt you don't make your plant automated and have the policies, like you have GNURM, you have ADB, you have World Bank fundings and all that. Until and unless you don't tie up with those funding agencies, I don't think you will have that muft pani and muft bijli, what you are hearing about Mr. Kejriwal and all that. Fine. So then you need a sustainable infrastructure development, that is asset optimization, planning, and O&M asset. Like you have to maintain the plant for not for 1 year, 2 years, but nowadays the contractors are being asked to maintain the plant for almost 10 to 15 years. That is a very long time, and you need to have the O&M spares assets with you. So and drive energy efficiency across the network. It's a better situation, since we can store the water and plan reservoirs, unlike electricity, where generation has to match the demand in the real time. Like nowadays we can go in for the smart grid system, wherein you have everything on your central control room. It's electrical panels, and you get the data on your in your central control room. Right? Then the solutions that implement pressure and leakage management. I was talking about the NRW, that is non-revenue water. That is the leakages which are taking place in the system, in the pipelines, in the pumps. So we need to maintain those leakages, and they are being done by monitoring those leakages. Like we have pressure transmitters, we have flow meters installed at each and every junction of the pipes, and we really need to reduce those losses. Fine. Then water saved is water produced. So this can help to plan the investment. And then we have to adapt an appropriate integrated urban water management strategy to drive a sustainable operation, because the plant is being run for almost 10 to 15 years. So we need to have a sustainable operations. So we need to manage widely distributed assets, like you have booster pumping stations located at 100 kilometers. So you need to have the data of all those booster pumping stations. What are the problems we are facing at the pumping stations, and even manage the energy consumption. So we need to install the devices which reduce your energy, like we have variable frequency control drives. Instead of simply a pump running, we can have a variable frequency drives wherein they get integrated with the flow meters, and finally they control your speed based on the flow. So it's basically a energy conservation there. Fine. And then you have to manage the pressure, like you have to pressure transmitters, pressure sensors, which senses your system and gives the signals to the SCADA system. Then you manage the leakages and so on. Fine. And to manage, we should know first what SCADA is. What is the full form of SCADA? SCADA means Supervisory Control and Data Acquisition System. Like you, from a central control room, you can manage the entire plant, and you need not to go to sites. You need not go to that area, particular area. You can control the whole entire plant from the central control room, and all the data is being acquired at the central control place. So SCADA is a supervisory control and data acquisition, and it's a category of software application program for process control and the gathering of the data in the real time mode. That is, real time stamping is being done. Like on your mobiles, you have a call logs. What are the call logs? What are the call history you have got on your mobiles? Similarly, in the SCADA system also, you have a data entry in the real time, even from the remote locations, in order to control equipment and the conditioning of that thing. Then what SCADA does exactly? It remote asset management and control. It optimizes asset operation and life and energy management. And you have a pressure management, thereby reducing the leakages and NRWs. It optimizes field stop operations, like you don't need too much of operators scattered over the area of the whole plant. You need only 1 or 2 supervisors and main operators in the control room, because those areas are being taken care by the SCADA or the programmable logic controllers which you have already installed there. So because it gives data to your SCADA system. At the same time, providing extensive online data to improve operational efficiency, and providing base for advanced applications, that is your ERP system, SAP system, and it can get integrated with your ERP system also, the SCADA system. Now take an example of a flow diagram. Have you ever seen a water treatment plant? Anybody of you? You have visited? So can you tell me just the components of the water treatment plant, what you have seen there? Okay. 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 You haven't seen any of the plant in Delhi?
Yes.
No? Okay. Okay. I was talking about this Sonia Vihar plant. Maybe you can go and have a visit to that plant, because that plant is designed by me. It has been actually designed by me, and this Bhagirathi plant in Wazirabad, that's being designed by me. So it's a fully automated plant, and you will just be very excited to see the SCADA plant at Sonia Vihar. Yeah, fully automated. Yeah. So this is a typical process flow diagram of a water treatment plant. Fine. You have a raw water source, and then you have an inlet chamber wherein you dose the chlorine and alum, And finally, you have a flash mixture for a random mixing of the LM and the water. Then you have a clarifiers. It's a circular structure wherein you have a scrappers, and these solid material is collected at one place, and then you have a filtration. And here the SCADA plays a very important role in the filtration plant, where you have, once your turbidity is high, you need to backwash the filters. That's why once your turbidity is detected, your backwashing starts based on the programmable controllers set in the PLC system, SCADA system. So the backwashing of the filters is done with the help of the controllers which are already fitted in the SCADA system. Then after that you have a clear water reservoir wherein your treated water is stored. And then you have the sludge management system where you have thickeners. It thickens the sludge by the application of polydosing, and then you have a centrifuge where it's formed in the form of the cakes. Sludge is formed, and then you can dispose it off, or you can sell it to industries or to the farmers as a manure. Then you have a UGR system, that is the underground reservoirs where the water is stored and it is being treated with the help of the chlorine dosing. And then finally it is given to the colonies. Now there are certain parameters, online parameters, which are being measured at every junction of the water treatment plant. That is, you have at the inlet you have a flow measurement, and then you have a level transmitter, that is ultrasonic type, in the inlet chamber. Then you have a pre-chlorination and LM dosing at the inlet chamber. And earlier these pre-chlorination LM used to be totally manually dosed based on the judgment. Nowadays you have a variable frequency drives which doses the LM and pre-chlorine based on the inlet. You have flow meters, you have turbidity analyzers, and based on that your automatic dosing takes place. Then you have pH, turbidity and suspended solid measurements. These are the online process parameters which are being used in the water treatment plant. And then finally you have the level transmitters, flow transmitters installed at every outlet, so that you know what is the leakage in the whole plant. And the signals of all these instruments plus your process instrument goes to the SCADA system. There it analyzes the things. And then you have a set points also, like if your turbidity rises about a set point, like you have set a set point of 100 or 200 NTU, and if it rises above 200 NTU, then your LM dosing starts. So your LM dosing starts based on the turbidity. If your turbidity is high, that it goes above the set point, then your LM dosing starts based on the logic developed in the SCADA system. And similarly, pumps which are scattered over the area of the water treatment plant, they are being controlled with the help of the level transmitters. Like once your level is low, the pumps will start in order to fill the reservoirs, and once the level is high, it's detected high, then your pumps will stop based on that, so that the water doesn't overflow from the tanks.
From the SCADA system you instruct these pumps?
Yeah, yes. It's actually a programmed thing, like you have various softwares for that. You have ladder logic, you have this sequential logics, you have functional block diagrams. Then all these programs are being fed into the SCADA, and then you give a set point for that. Like once you know the height of the tank, suppose it's 5 meters, then you set the set point that at 3 or at 2 meters it should start, yes, and at 6 meters it should stop. Like you feed the program in the SCADA for that, right? So similarly you have all these signals going to your SCADA system, and these are being controlled, and you get a real time real time data. Like you know that this time the flow was this time the process pH the value was this, and why did the pump trip, when did the pump trip, every data is being sent to the SCADA system. Then this is a simple system architecture of the SCADA system. Can you just, any one of you explain me by seeing this? Just as a layman this thing. Yes. Nobody? Computers तो देखे ही होंगे आपने. So you have a 60-inch display screen, you have a very big screen like wall-to-wall screens where you have various screenshots and you can see each and every area of the plant. You can analyze each and every area, what's going on there, which pump is starting, which pump is stopping, which has tripped. So you get screenshots on your display system. Yeah, this is a typical system architecture wherein you have a display system, then you have a computers, you have a server system, you have an engineering station wherein you can feed the programs in the engineering station, and you have an operator station. Normally, a operator isn't allowed to sit on the engineering station because it's you have to maintain the secrecy of the system, like what is the program fed, what is the set values, and what are the values of the process parameters. So normally the operator works on the workstations, operator station. Then you have a remote PLC systems, like you have a remote PLC systems at each locations. Nowadays what we do, that we have a redundant PLC system, like if one processor fails, the other is being taken over. So all the programming from one is shifted to the other, so that we have a fail-safe system. It's a fully diagnostic system is there, and if one processor fails, the other will take over. And all these signals are communicated to the SCADA system through a fiber optic network. You can see a red one communication line, that is a fiber optic network nowadays. So in every cities you are seeing nowadays a fiber optic network being laid down. So it's a very, this is the fastest means of communication nowadays, and with the help of this fiber optic communication, all the data from the various areas of the water treatment plant are being fed to the main control room. Then this is a typical consolidated system architectures, wherein you have a booster pumping stations located at each remote areas. Then you have a remote transmission unit at each booster pumping stations, and from these booster pumping stations, all the data of the pumps, all the data of the flow, all the electrical data are being consolidated at central control room. Then you have these RTUs which work on the GPRS system or GSS system. Like similarly, you have a SIM on your mobiles. So similarly, like this RTUs, they have a SIM card wherein they work on a GPRS system or GSM system. Even you can have a radio frequency system nowadays, or satellite. Via satellite we can also communicate the data. Finally, SCADA in the central control room, it consolidates all the data, it provides a global asset overview, and it manages the remote applications also. And even it manages the local processes also. Like you have WTP1 wastewater treatment plant in the same area. So it can have an integrated data of all the processes. Now, I was telling about the Bhagirathi which we had commissioned recently. So what was the present scenario of that plant? Let's take a case study of that. Presently, it is fully manually based systems. We don't have any controls, we don't have any signals going to the SCADA system, we don't have any automatic control of the dosing of the pumps. Now, the plant receives water from river Yamuna through Sangam raw water pump house when the canal is closed. At present, there is zero monitoring and control. Then you have substantial losses of water, that is almost 10 mgd of water is being lost from clarifiers, from sludge drainage, and from filters. There is no control of the chemical dosing system. It is simply a conventional plant with 8 clarifiers and 40 filter beds. And all are being manually controlled. These filters, you don't have a filter backwashing system, you don't have a PLC control, you don't have a SCADA control there. It's a manually operated, you have UGRs, that is underground reservoirs, you have booster pumping stations, and the data of those are not being communicated to any central control room, because you don't have the communication system there, installed there. Now, what is after automation? Now, what we did, we actually made the plant automated with all the civil, mechanical, and rehabilitation works. Like you didn't have the flow measurement, you didn't have the pressure measurement, you didn't have the process measurements. We installed all those instruments in line in the entire plant. And now, and we did the design, installation, testing, commissioning, and even the operation maintenance for 11 years. Then you have a redundant PLCs at each 100 mgd WTP, and you have a IO, that is remote IO at sludge, pump house, and recycle plant. Then you have a PLC system installed at a Sangam raw water pump house which communicates to the main control room in the water treatment plant. Then you have a fiber optic network which is laid entire in the water treatment plant and it communicates with your main SCADA system. Then you have a chemical house which is totally an automatic dosing takes place. And then it was a very big challenge to install a flow meter in 2.8 meter pipeline which was almost full of water. So it was very big challenge for us. And then you have a recycle plant and a new 10 MGD water treatment plant which we designed for that. Because the sludge, the water from the sludge, it needs to be reused. So you need a recycling plant for that, wherein you have a sludge thickeners, you have a centrifuges. So we had installed all those things. And then you have a central control room which comprises of the server's computer, client PCs, displays, printers and UPS. These are the major components of the SCADA system. Then and you had a SCADA at Sangam raw water pump house also. So all the data of pump houses, you can see that this was a pipeline and we had to install a flow meter here. It was 2.8 meters pipeline and it was running and they were not giving the, DJB was not giving the shutdown period for us. They said that you have to install a flow meter and you need to get the flow data. So what we did, you can see a person standing there on the wall, though it was very tough, but he tried to install the system there and it was a teledyne system which actually is based on the Doppler principle. It's an ultrasonic sensor which is being installed at the bottom of the pipe and then you get the flow data from that based on the Doppler principle, ultrasonic principle. And you can see the person standing there and installing the sensor just on the pipeline and you can see we had installed a frame here and the sensor was being dipped into the water. This is a flowing water. You need not have to shut down and everything. It was just inline you have to install. And from this control box, your data is going to the central control room. It was almost 50, almost 100 meters, almost 100 meters. And then you lay a cable from there to the central control room so that your data flow meter is going to your central control room. Now these are the typical graphic screens wherein you have a physical representation of each pumps running, tripped, when did it trip, what is the timing for that, when it tripped and why did it trip, what are the normal alarms which are coming into the system like level high, level low, turbidity high, turbidity low, pH high, pH low. All these data you can see graphically on the screens and then you get readings on your screen itself. You even can generate an alarm history like the real-time alarm history. You can generate a flow trends like at this point of time your flow was this, at this point of time your turbidity was this. You can generate the trends also in the graphic screens. And then you have a typical system, this graphic screen of a sludge, sewage treatment plant wherein you have sludge thickeners, you have pumps and you get the data of each and everything like you have what is your turbidity, what is your sludge density, all the measurements you get on the graphic screens. Then you can see a typical panels. These are the electrical panels. In earlier days, you used to have a conventional plant where panels, wherein you used to have a lot of cabling. Nowadays, because of this SCADA and these are microcontrollers, you need to, the cabling has been reduced drastically. Like there's a minimum use of cabling because you have a serial links between the electrical panel and the control panel. These are the control desks which I was talking about. These are used for the filter consoles. Here inside it you have a programmable logic controller which controls your programs. It's already fed into the system and it does the backwashing automatically based on the turbidity level. Then you have a control panel. You have an input. Basically what is SCADA or what is PLC, programmable logic? It's an input, it's a processing device and then you have an output device. Input may be in the form of the selector switches, push buttons or keyboard. Then you have a control panel wherein you have a push buttons, you have a start stop selector switch, you can start stop the pumps physically from the control panel or you can start stop the valves, automatic valves from the control panel. basically it's already fed into the PLC, but if you want to manually operate the plant, you can do it that by bypassing the auto system, fine. And then you have the indicators also, like you have level indications, flow indications on the front view of the control panel. And you have a handheld terminal. It's based on the RF radio frequency principle, that you can control wherever you are in the plant. You can hold a handheld terminal and you can control the plant. You can stop the plant, you can run the motor, you can stop the motor, fine. This is a SCADA system components. Basically, it's a display screen. You have a client PC, you have a server computers, you have redundant PLC system, you have remote IOs at various locations of the plant. Then your RTU, that is remote terminal unit at the booster pumping stations or at the distribution areas. And this is a central control room wherein you can see a big display and you can get a screenshots of each and every area. Even nowadays your CCTVs, you have cameras and everything, that can be integrated into your SCADA system nowadays. So you can view, one screen will be of that, like you can view what is going there. Maybe some operator is going and deliberately switching off the pumps or doing some mischief. You can see on the screen from the central control room. Now we can see that what are the advantages of automated plant versus conventional plant. What SCADA does, SCADA actually saves a substantial amount of energy and raw water material by turning operating data into the information. It provides 100% self-diagnostic coverages, like it can diagnose your system. If you have a fault, what is a fault? What is a fault? It's because of there's a problem in the electronic card, there's a problem in the power card, then you can immediately call your vendor and tell him to rectify the same. Then you have sensor data reconciliation, that is, it reconciled failed or faulty sensors. If you have a faulty sensors, we can have a spare for that and it can be replaced immediately. Then you have a proactive fault and abnormal condition monitoring. Then it reduces the manpower cost. As I told you that we need minimum amount of manpower in the SCADA based automated control system. And then it reduces the cabling cost also, and it reduces the water losses also, because you have monitoring system at each and every junction of the water treatment plant. Then your dosage, which was being done based on the judgment earlier in the conventional plant, nowadays it is being controlled, automatically controlled, like your poly, LM and all these chlorine dosing is being automatically controlled. Then you have auto operation of the pumps, which increase the efficiency, because you know when you have to start the pump, when you have to stop the pump, and based on the flow you maintain your speed of the pumps, and hence it increases your efficiency. Then it gives the real-time process optimization, resulting in the energy saving and cost saving, because you come to know when your plant, when your motor needs a maintenance, because you have a call history, call log there, that this pump has run for almost 8 hours, now I need a maintenance, or this pump has run for 24 hours, now I need to turn on to the next pump. So you all the call history of the pumps, and it reduces your process information overload on operators and engineers. Then it captures and retains process knowledge and spread across the plant personnels. It maintains better quality of control and desired process and products. It reduces downtime due to unnecessary process shutdowns. You need not to do the process shutdowns like in the conventional plant.